Hi everyone and welcome to Chapter 4, Lecture 3. This is all on solution stoichiometry, and we're going to also look at concentration and how to use that. So just to review, solutions are made up of the solute and the solvent. So the solute is what is dissolved or what is in the lesser amount. So typically the solute is going to be the solid. You can have solutions that are both liquids, but typically it's going to be the solid that's being dissolved. Then you have the solvent. The solvent is the substance that does the dissolving. Typically it's water because water is the universal solvent. Solutions can be classified two ways, as an electrolyte or as a non-electrolyte. Electrolytes conduct electricity. Remember, conductivity is based on how many ions are present in solution. And then a non-electrolyte is a solution that does not conduct electricity. Typically, they are molecular compounds that don't dissolve in water. So, components can make up a miscible mixture or an immiscible. So, miscible means that they mix. And that's the way to think about it, miscible and mix. So, if two things are miscible, then they're going to mix together. So think like alcohol and water, right? If you put rubbing alcohol in water, they mix. You can't tell the difference. Immiscible will not form a solution. So you put two immiscible liquids together, they will not mix like oil and water. So there is a limit to how much you can put in, and that is the solubility of the solute. So the more solid, for instance, that you can put into water, the more soluble it is said to be. Solubility can be expressed by discussing if something is soluble or insoluble. Remember, slightly soluble and insoluble, those terms are interchangeable. So if something is soluble, it mostly dissolves. If it's insoluble, then it does not. Again, slightly soluble is in between, but typically you can't see it. When it's slightly soluble, it just looks insoluble, so that's why those are used interchangeably. So concentration. The concentration of a solution refers to the amount of solute that is dissolved. Qualitative terms used are dilute and concentrated. So qualitative means that it is characteristic qualities, has nothing to do with numbers. So dilute means not much solute, concentrated means a lot of solute. You always describe solutions based on how much solute you have. Another thing to make note of is that concentrated does not mean pure. Okay? Those are two completely different terms. So molarity. Molarity is the most common way that we talk about concentration. Molarity is the quantity of solute that is in a given solution. We also call molarity concentration. So if I ask you to calculate concentration, I'm asking you to calculate molarity. Okay, molarity is moles of solute over volume in liters. So it's moles of solute over liters of solution. Make note that this is solution. Okay, molarity is most often used later in the year when we talk solely about solutions. We're going to talk about molality, normality. We might not necessarily talk as much about formality. This is really old. Mole fraction, percent by weight, percent by volume, so on. So there are a lot of different ways that we can talk about concentration. Molarity is the most common. Molarity can also be represented using brackets. So if you see this bracket, that tells you that that is the concentration, or that's the molarity. To think about molarity, you can think about the for every statements. So if we think about this fraction right here, we could say, let's say it's 1 molar. Okay, let's say we have a solution that is 1.0 molar. So what this means is, for every 1 mole of solute, we have 1 liter of solution. Or for every 1 liter of solution, we have 1 mole. If instead it's 2 molar, that means for every 1 liter we have 2 moles. So remember, we can keep using those for every statements as we go through. So molarity can actually be used as a conversion factor as you go through stoichiometry. So as you do this, you can use your molarity to get to moles, right? So if you have volume and molarity, you can get to moles. Then you can just continue stoichiometry using the mole ratio. You can go to grams using the molar mass, and so on. A problem-solving strategy that you might want to use as you work through these problems is first figure out what you have present in solution and determine what reaction occurs. Then write the balanced net ionic equation. So we talked about net ionic equations in the last video. You always want to write that net ionic equation and balance it. Then calculate moles of reactant. So whether that means use molarity and volume, maybe you're given grams, but always go to moles. Make sure you figure out which reactant is limiting. Okay, don't forget about that. And then go through like a normal stoichiometry problem. Calculate moles of whatever you're being asked about, and then convert to grams. Or once you have moles and you're given molarity, you can go to volume. So there are a lot of different ways that you can use this map to help you through stoichiometry. So mixing a solution. So now we're going to get back to qualitative for a little bit. So mixing a solution, to create a solution of known molarity, you need to weigh out your known mass, okay, therefore you know your moles, of the solute. So you're always going to use our electronic balances. You're going to measure out the exact mass. If you need 0.200 grams, measure out 0.200 grams. If, let's say you can't, you've been trying and trying, but it's 0.201, that's fine, but you have to recalculate the molarity. So once you have your known mass, add your solute to a volumetric flask. Okay? If you look, this is a volumetric flask. The volumetric flask is based on a specific volume. So if you need 250 milliliters of solution, you need to grab a 250 milliliter volumetric flask. If you need 500 milliliters, you grab a 500 milliliter volumetric flask. You have to make sure that your flask matches up with the volume that you need. So you add the solute to the flask. First, you want to add a little bit of water. Mix it up a little. Always use distilled. So you want to mix it up a little bit, swirl it, let it dissolve. Then fill it, typically with water, to the line on the neck of the flask. Make sure you are exactly at that line. And these volumetric flasks are the best way to mix a solution. Never use anything else. Always use a volumetric flask. So there is this video in the resource section on the class website that talks about forming a solution from a solid. I highly recommend that you take a look at this video because it's going to walk you through step by step what you need to do. So we talked about forming a solution. Now we're going to talk about dilutions. So before we talked about dilution being not as much solute compared to the concentrated version. So you can dilute a more concentrated solution by either using a pipette to deliver a specific volume to the volumetric flask and then adding the solvent to the line of the new flask. Or you can also, if you don't have a pipette available, use a graduated cylinder, determine how much you need, and then you put it into your flask. So step by step, what you should do is measure out the stock solution. So that's the solution that you are diluting. Measure out how much you need, and we're going to talk about how to figure out how much you need. Okay, place it in a volumetric flask that contains the volume of the diluted solution that you need. So either 100, 250, 500, 1,000. If you need 2,000, but you're never going to need 2,000 milliliters. And then you'll fill the volumetric flask to the mark on the neck of the flask with distilled water until the meniscus hits that mark. That's your new solution. So you might be saying, well, why would we need to dilute? Well, for an example, in the acid cabinets, we have 18 molar hydrochloric acid. If you guys worked with 18 molar hydrochloric acid and it splashed up even on one of the gloves that you're wearing, it will burn through, it will eat at your skin. So I have to dilute these acids to make them workable for the lab. You guys might have to perform dilutions to dilute your own acid to work with in the lab. So with these dilutions, you can actually determine the molarity or even how much you might need by using the equation really M1V1 equals M2V2. So this represents C and D. C represents concentrated, D represents dilute of each of the respective solutions. But you can use M1V1 equals M2V2. Something important to remember, volume, these need to be in the same units. Okay? If one is given to you in milliliters and you're asked to find the other volume, that's fine. Just remember that it's also in milliliters. But if you prefer to convert to liters because that makes your life easier, then go for it. So I talked about a pipette. Now I don't know how much work you've had with pipettes, but a pipette is a device for accurately measuring and transferring a specific volume of solution. So you have two pictures of pipettes on here. This top picture is what's called a graduated pipette. You can see if you look very closely there are a lot of markings. This is used to measure volumes with graduation. So maybe you need 2.5 milliliters. You might want to use this graduated pipette. Or you can have this picture at the bottom. This is either a volumetric or a transfer pipette. The names are interchangeable. These give only one volume to be measured. So maybe it's a 5 milliliter pipette or a 10 milliliter pipette, but it only gives one specific volume. These are very, very accurate. So if you have to measure out 10 milliliters of something and you have a volumetric pipette available, use that. So just like with forming solutions, there's a video in the resource section of the class website on diluting and how to dilute a solution. So make sure you take a look at this video. It will definitely help you out. And then finally, we're going to talk about titrations. We're going to get a lot more into titrations when we talk about acids and bases later in the year, but you will need to know some general aspects of a titration right now. So a titration is an analytical technique in which you can calculate the concentration of an unknown solution. So when titrating, what you're doing is you're working with an acid and a base. So you're neutralizing them. You're adding the acid with the base or the base to the acid. And then you'll actually use the balanced equation and the molarities to determine the unknown. And typically what you'll do is you'll set it up just like a neutralization. You're going to be given molarities and you have to find moles. As you work through titrations, you might see a couple new terms. You have what's called a titrant. Okay, the titrant is what is being delivered from this burette. Typically it's going to be sodium hydroxide, but the titrant is what is coming out of the burette. The analyte is what is in the flask at the bottom. That's what you are analyzing. So you either need to know its mass or its volume in order to calculate the unknown. So with a titration, again, you have this kind of map up here. The volume needed to reach the equivalence point, you can use the molarity to find moles, use your balanced equation to find moles of the unknown, and then you can find the concentration of the unknown. So the solution of known concentration is called a standard. You guys will actually standardize a sodium hydroxide solution later in the year, but a standard just means you know the exact concentration. So maybe it's 1.015 molar. That is what is being used to determine the unknown concentration of something else. The equivalence point is when the reaction is complete. The equivalence point is typically when your indicator changes color. So if you're using phenolphthalein, it's when it turns pink. The equivalence point is when moles of acid equals moles of base. This is why we can use the mole ratio. So maybe it's 2 moles of base to 1 moles of acid. Well, that's why you use that mole ratio, because the equivalence point is when they are equal. So this just shows you some setups for titrations. So what you're going to do to start is you put your unknown solution into a flask. You set up your titration. So in this case we have acid below. We have sodium hydroxide as our titrant. And then you're adding it until it changes color. So as you guys probably remember from last year, it just takes 1 drop for it to go from very light to very dark. The neutralized solution, that's your endpoint. That's when it has changed color. And then you can take some look at these pictures at the bottom. So you see that it starts clear, and then as you're adding more NaOH, it starts to get more pink. and then your equivalence point is once it turns pink and stays pink. And then finally, you have a video of an acid-base titration in the resource section. Please take a look at this because this will be very helpful as you're working through with neutralization and with titrations. Please make sure that you look at each of these videos. They're about 1.5 minutes each. You don't have to watch them all right now, but just make sure that you take a look at them because they are very detailed and they do walk you through everything that you need. So if you have any questions as you work through this video lecture, please let me know. You will find that you have more of the examples. You have those QR codes and the links on your notes to scan and watch the example problems if you need it. You know, you don't have to watch all of them. If you need help on all of them, I would recommend it. So again, let me know if you have any questions, and have a good day.